This is Limits Day 1 Notes. And this first problem right here is review of your limit as x approaches infinity. And I always think of my horizontal asymptote rules because I have a common denominator. Because the bottom is the biggest denominator, that would be low over high, so 0 equals y. So it looks like as x approaches infinity, my limit is going to approach 0. Or you can think of this as bottom heavy, so it's still going to approach 0. You could also enter this into your calculator and look in your table, or you could just look at the graph, and the graph is going to look like this. It's going to be a rational function. So you can see as it approaches 0, there's going to be an error. Okay, so that's why it's going to approach 0 as it goes towards infinity. Okay, so the definition of a limit, if your function becomes arbitrarily close to a single number, L, as it approaches C, and this is your C right here, from either side, then the limit of f of x as x approaches C is L. So what this is basically saying now is that we are not necessarily going to see a limit right here on all these. We're going to see a number now. Okay, so how would we do this as x approaches 0? All we need to do is plug in a 0 for your x value. So I'm going to say 5 times 0 minus 3 to see what it approaches, and it's going to approach -3. And for this one, if I plug in a -1, and be careful here, because I say 4 minus, and then I'm going to plug in the -1 for your x value, and that's going to be cubed. And so 4 minus -1 cubed here is going to be a -1 still. So 4 minus a -1 is going to be 5. When I plug in, I guess that's a 6. So as x approaches 6, that's going to be 5 times 6 minus 3. And that answer should be 27. So according to these functions, as x approaches this number, that's what the limit approaches 27 here. Okay, so what these three functions say here, for your limit as x approaches r, your function is going to be continuous. Okay, so let's look at this next function here. It says, as your limit, as x approaches 2, what happens here? So the first thing I would do, just like we did on the other one, is I would plug in a 2. So I've got 2 squared minus 7 times 2 plus 10 over 2 minus 2. And as you can see right here, 2 minus 2, that's going to give me a 0 on the bottom. And you know that you can't divide by 0 on anything. But I'm going to keep going. This is 4 minus 14 plus 10. So 4 minus 14 is a -10 plus 10. And this is going to give me a 0 over 0. Okay, so a little hint here. If you ever get a 0 over 0, or if you get a number over 0, which is undefined, or if you, well, I'm just going to leave it like that. Then your function is, let's see, your function is not continuous, like the ones we had before. So what are we going to do if your function is not continuous? Well, what I would do, first of all, is you're going to say that your limit as x approaches infinity, or I'm sorry, 2, and I would factor this. So the top is going to factor to x minus 2 and to x minus 5, and the bottom stays to x minus 2. And if you notice, your x minus 2s are going to cancel out. And what happens if you remember when they cancel out? That becomes a whole. So now I just have as my limit as x approaches 2, I just have x minus 5. And that is just my function. So if you notice, this is just going to be a linear function. So now I can plug in my number of 2. So 2 minus 5 and my limit approaches -3. The value of the limit is related to the behavior of the function near x equals 2 and has nothing to do with the value of the function at x equals 2. All right, on these graphs, it says as the function, okay, for these graphs, it says find each limit. As the limit, for the limit of this function as x approaches 2, so what we're going to look at is a function. So as the function approaches 2, here's 2, it gets closer to 1. And when the function goes this way, as it approaches 2, it gets closer to this point right here. So I would say as the function approaches 2 from both directions, it gets closer to 1. On number 6, it says the limit of this function as it approaches 2. So here's 2. When it approaches 2 from this direction, it approaches, looks like it approaches -1. And when it approaches 2 from this direction, it gets closer to 1. So it's 1 this direction and it's -1 this direction. And so the function cannot get close to 2 different numbers. So I would say the limit does not exist. So number 7, it says as x approaches 0. So as we get closer, I don't think I can trace this one. So as we go from the right side and approach 0 from this direction, I could not tell you what that number is. And as we approach 0 from the left side, I don't know what that number is either. So I'm going to say that it does not exist because I can't read that number since it's oscillating. Okay, so when we approach 1 from the right side, on this side, we're approaching 1. It looks like it's getting closer to -1. And as we approach it from the left side, it looks like we're also getting closer to -1. Limits that fail to exist. Behavior that differs from the right and from the left. So if I say the limit as x approaches 0, and why I keep saying from the right and from the left is we have to do both sides. So as it approaches 0. So let me just sketch a graph here. If I wanted to know as x approaches 0, as this is absolute value, so I could say absolute value going from that way and from this way. My limit would not exist because it is going in 2 different places. Remember, your limit cannot be a positive and a negative there. So this would not exist. Okay? Would my limit exist if I changed it to a number like 5? So let me draw that one here. Still would look the same picture. So let's look at 5. Would my limit exist if I looked at the number 5? Well, here is 5. My limit would exist if I give it a limit of 5 because at 5, my limit would be 1. Okay, so you could plug in a 5. The absolute value of 5 over the absolute value of 5 is 5. So 5 over 5 is 1. I got that by just plugging it in. Okay, and that would exist. Okay, an unbound behavior. As the limit as x approaches 0 of 1 over x squared. Okay, if I plugged in my 0, that's still 1 over 0. So I have 1 over 0, and that would be undefined, right? So that means if you looked at your picture, 1 over x squared is this picture right here. Okay. And you could look at the graph. This was one of your parent functions that we looked at before. By choosing values of x close to 0, you can force your function to be as big as you want. Because your function is not approaching a real number, L, as x approaches 0, the limit does not exist. Okay, an oscillating function. We looked at one, number 7 was oscillating. You can plug this into your calculator. In fact, it would be nice if you did so you can look and see what it looks like. I can sketch this one for you. You can plug this in. You can plug in a 0 here, but this is nice to kind of look at and see to see the graph. When you plug in sine of 1 over x, you get something like this. Let me see if I can sketch this one. Graph. If you look in your table, or you did a trace of x equals 0 to see what your y is, you get nothing for your y. Or if you look in your table at x equals, there's an error on your y. Okay, so there is no y value at all. So although it looks like it passes over your y, there is nothing there. So since there's nothing there, then we would say your limit does not exist at 0. That's what we're looking for. So just like this behavior up here, your sine of 1 over 0 would not exist. Okay? Remember, the limit as x approaches c of your function does not depend on the value of f at x equals c. Okay. It says compare and contrast your function x squared minus x over x squared minus 1 over x minus 1 and g of x of, this is a mistake here, this should be x plus 1. All right, so let's see, f of x equals, this right here factors, so I'm going to go ahead and say x plus 1 and x minus 1, and that's over x minus 1. And like a function before, this cancels out, so that means there's a whole. Okay, so I just end up with x plus 1. Okay, so I'm going to say, therefore, I have a whole at 1, 2. And I got that by saying negative 1, plugging it in here, negative 1, a whole at 1, plugging it in there to get 2. Okay, so I'm just comparing those. Okay, now they say find the limit as x approaches 1 of these. Now you can plug in your 1. So that gives you 1 squared minus 1 over 1 minus 1. And that gives you a 0 over 0. Now remember before we said when you get a 0 over 0, that means you do not have a continuous function and you need to go ahead and figure out why. And usually that means you have a whole. So I'm going to say the limit as x approaches 1, and I'm going to factor this. So this is x plus 1, x minus 1, over the x minus 1, and there's your whole. So I have a limit as x approaches 1 of x plus 1, so that's your function. So the limit should approach 2. Okay, the same here. You can plug it in if you don't already recognize this one. Plug in 1 squared minus 1 and 1 plus 1. So you get 0 over 2 and a 0 on top. Still, this is going to be a discontinuous function. So I'm going to continue this and figure out that I have a whole. So x plus 1, x minus 1 over the x plus 1s. And we're going to figure out what this limit approaches. And this limit is going to approach 0. Some functions obviously do not have limits. You can tell ahead of time if manipulating the equation will allow you to find its limit. If direct substitutions allow 0 over 0, this is called an indeterminate form. This means that the limit does not exist, but that the function is currently in a form that causes the limit to be indeterminable. Okay, so if the limit as x approaches negative 3, plug in the negative 3. We're going to square it. I'm going to add a negative 3 and subtract 6. Negative 3 plus 3. Okay, I know I'm going to get a 0 on the bottom. I don't care what I get on the top. I know that I can factor this more. So I'm going to say as the limit as x approaches negative 3. So the top I can factor to x plus 3 and x minus 2. And bottom is going to be x plus 3. So I have a whole. Remember, that means that you have a discontinuous function. So this means the limit as x approaches negative 3. So that's x minus 2. So your function approaches negative 5. Okay, this bottom one, this is negative 5. I'm squaring that. Minus 3 times negative 5 minus 10. And negative 5. Oh, I'm getting a 0 on the bottom again. Okay, so this factors again. Remember, this is discontinuous. So let's see. X minus 5 and x plus 2. Okay, so I don't have a hole on this one. I just ended up with a 0 on the bottom. Okay, so I am still going to plug in my negative 5, and it ended up with the same thing that I got here. So my limit, I'm not going to do that. Since I can't factor anything out, I'm just going to plug in my negative 5, and I got 30 over 0, so my limit does not exist.